behind the drywall of your favorite sports bar or even a corporate boardroom, there is this silent war happening.
Yeah, between high voltage physical hardware and low voltage digital networks.
Exactly. So today our mission for this deep dive is to really look at the tiny diplomat brokering that peace. We are pulling directly from the HDTV Supply catalog to examine the Kramer FC-7P control gateway.
Right, because our goal is to figure out exactly how this single compact device bridges the gap, going from a digital packet on your network to a heavy projector screen actually rolling down from the ceiling.
And without overwhelming you with IT jargon, hopefully.
Right, because it is the perfect case study for understanding the actual mechanics of how our physical spaces are being digitized. I mean, the gap between clicking a button on a tablet and a motor turning on is, well, it's much wider than we usually think.
Okay, let's unpack this. Think of the Kramer FC-7P as like a digital puppeteer.
A digital puppeteer, I like that.
Right, so the local area network is the script.
Yeah.
The FC-7P is the brain reading that script, and its GPIO and relay ports are the literal strings pulling the physical hardware.
Yeah, translating low voltage data into high voltage action.
But how does a digital ping over an IP network actually pull a physical string, like physically?
Well, a relay is essentially an electromechanical switch. When the FC-7P receives a specific digital packet over the network, it sends a tiny voltage to an electromagnet inside the relay.
Oh, so it uses a magnetic field.
Exactly. That magnetic field physically snaps a metal contact closed. And that closure completes a totally separate higher voltage circuit. Like the AC power running to your motorized shades or your projector screen.
So a tiny digital whisper creates a magnetic pull, which then physically slams the gate shut on the high voltage power. That makes perfect sense.
It does, and what's fascinating here is how it actually gets the power to run its own brain and those electromagnets.
Because it uses PoE, right? Power over Ethernet.
Yes, because the FC-7P is PoE compliant, you aren't reliant on an electrician to drop an AC outlet directly behind a display or up in the rafters.
Right, which is always a nightmare.
Oh, totally. If you've ever had to snake power cables through a dropped ceiling, you know why doing this strictly over a single Cat6 drop is a massive lifesaver. It drastically reduces cable clutter.
Yeah, getting physical relays to execute commands via PoE is great, but moving that command layer entirely to an IP network, I mean, that feels like a recipe for a traffic jam.
You would think so, yeah.
So here's where it gets really interesting. The spec sheet reveals this gateway supports up to 40 simultaneous IP clients over the LAN.
40 clients?
Wait, putting AV controls on a local network with 40 different devices sending commands at once? How does a tiny box process all that without choking? Or, like, executing conflicting physical actions?
Like one tablet sending a lights up packet while a phone sends lights down.
Exactly.
Well, the FC-7P doesn't just blindly fire relays the millisecond a packet arrives. It actually acts as a traffic cop.
Oh, so it buffers the commands.
Yeah, it queues the incoming TCP/IP commands and processes them sequentially. So even if 20 waitstaff in a restaurant tap their control apps at the exact same second, the gateway buffers those commands and executes the relay closures in order.
That buffering explains how it maintains stability under pressure. It completely prevents the physical hardware from receiving crossed signals.
Right. And if we connect this to the bigger picture, you can see how this radically shifts room design.
How so?
Well, in a massive sports bar with dozens of screens, your staff isn't fighting over a single master IR remote anymore, or running back to a central AV closet.
Oh, I see. Because 40 different devices can be the remote.
Exactly. Staff phones, wall-mounted iPads, laptops, they can all concurrently act as the master controller. The command center is completely decentralized.
But wait, if it's fielding buffered commands from 40 different users at once, and physically switching electromagnets to control high-voltage gear, where does it actually sit in the room?
That's the best part.
Because you'd think a network hub doing all this heavy lifting would be some massive, noisy rack server, right? I'd worry about heat dissipation or latency if it's just stuffed in a wall cavity.
You definitely think that, but it's surprisingly stealthy. It's actually a fanless aluminum box under 5 inches wide.
Wow, under 5 inches.
Yeah, and weighing just 0.4 pounds. Kramer designed it for this piggyback installation, meaning you basically just zip tie or mount it directly behind the TV display itself.
Right, hiding it right out of sight.
Exactly. And because it utilizes a built-in Web UI for remote management, once it's mounted behind that monitor, you just access it over the network to update firmware or tweak the relay settings.
So you never actually have to climb a ladder to physically touch it again.
Never.
So what does this all mean? It means true environmental control is becoming entirely invisible. We are moving past the era of clunky control boxes and visible wires into a space where the room just automatically responds to the network,
The hardware is completely dissolving into the background.
which leaves us in a really interesting spot.
It does, and this raises an important question. As tiny, hidden gateways like the FC-7P seamlessly wire our physical environments into our local networks, how long until the very concept of a physical on-off switch bolted to a wall becomes a total relic of the past?
Man, finding a light switch is going to feel like looking for a rotary phone.
Oh.
The tech is getting so good, we're going to completely forget the strings were ever there to begin with.